So we were talking about what pushes mammals to the water. Where is this? Here, maybe? No, not here. Not here. So what do I want to share this? Okay. So, sorry, I need to focus. So we're talking about competition. So competition with other species would push one species to a new environment. So that's a force. And then one of you said, well, the fact that animals are weightless in water, well, the fact that they are weightless in water is not an evolutionary force. So it's a fact, but not an evolutionary force. So why would the question is, why would an animal that evolved to live outside of the water, right, would then be reverse the adaptations or develop new adaptations to go back in the water? It's not something that they think about. It has to do with evolutionary forces. So competition is one evolutionary force, right? So if there's not enough food in one area, but there's food in another, then animals would have an evolutionary drive to new adaptations. Because this you need, well, imagine this, animals need adaptations. We've just talked about the temperature, right? For instance, and so in addition, to summarize, in addition, when I did this review, and I haven't finished it, but I was looking at specifically to mammals and mammals that live in the water or near the water or are depending on the water. So I took this Wikipedia page and I looked all the groups of mammals that are cited there as aquatic. And what I've realized is that some animals live near the water for protection. I would say for protection, right? So they don't actually eat things like primates, for instance. There are several species of monkeys that always live near rivers. And from my perspective of their biology, I would say that they live near rivers as a protection from predators, because they don't eat aquatic food. They can swim, but they don't spend a significant part of their time in the water. So, but they prefer riparian habitats. So they're always found in marshes, in the margins of rivers. And I would say that this is a form of protection. So to competition, I would add predation as something pushing mammals into the water, right? For instance, and there may be other factors. So, but moving on, because we must move on. I found this paper is interesting because what the author did was look to the evolution of, in this case, marine mammals. So this paper is just dealing with marine mammals, and the author looked at the oldest fossils of what was to be the marine mammals, right? So they looked at the ancestors, like the ancestors of present-day marine mammals, so terrestrial animals moving into the water. And what he found was this: he found that I'll read what you have here. It said the earliest representatives of each clade all show morphological features that indicate they were feeding while in the water, suggesting that feeding ecology is a key factor in the evolution of marine mammals, right? So coming back to what we just said, maybe competition is a big factor here, right? Because why would they feed in the water? They would, and the answer would be, well, they feed in the water. So for a terrestrial animal to start feeding in the water, that means that there is more food in the water. Either because there is a competitor eating what's in land, and so leaving the animal to the water, or because there's simply more food in the water, right? The aquatic environment is often much more productive than the terrestrial environment. So they just, maybe in many conditions, there may be much more food in the water than outside of the water. So this is an interesting perspective. The major factor in the evolution of marine mammals is food. They go in the water looking for food. And in fact, there's an interesting issue happening right now in Portugal. I don't know if you have this in Spain, for instance, but we have this recurrent pieces of news of how do you call these animals? Javalis, wild boars coming down from the woods, from land, to feed in the sea, right? So wild boars feeding on, in this case, mussels in the oh, sorry, existe um vídeo aqui, sorry. There should be a video. Let me see if this is still on, and if we still can see it. I don't know. This is an old link. Maybe it's gone. Yeah, it doesn't work. Anyway. So I can imagine that this would be something similar to what happened in the early stages of marine mammal evolution. So a perfectly terrestrial animal, not going in the water in the beginning, but looking to prey on aquatic organisms and aquatic food. And then eventually developing adaptations to be more efficient in eating aquatic food. So eventually these wild boars will be, in a few million years, will be another group of marine mammals. Who knows, right? And today we have seen from this perspective, animals like the otters, and even the polar bear, can be seen as transitioning from a terrestrial environment to the marine environment. Okay, so in the carnivora group of mammals, you have the polar bear, for instance. Now, the polar bear is, I have this video, and I'll put the video on while we talk. And this is the video of sorry, let me. You will not be hearing the sound, but I am. So let me just turn off the sound. So what we have here is a story, of course, being told of a very, as you can see, a very emaciated polar bear. So polar bear is obviously hadn't eaten for quite some time and is hungry, and they're going over the ice looking for a seal, and eventually it will catch the seal. So polar bears are considered marine animals because technically this animal is in the sea and it's preying on sea creatures. Again, food driving the evolution of marine mammals. And of course, this animal has adaptations to live in this environment, right? Is white. However, the fur is adapted to swim and to keep the body warm, to enable the animal to stay in the water and in these cold temperatures for at least time enough to catch its prey. Now, polar bears they're called the species is what's the species? Ursus marinus, maybe? Yes, thank you. But it's very close to the brown bear, and in fact they can interbreed, right? So brown bears and polar bears are so close that they can interbreed, right? And so the split between polar bears and brown bears happened very recently in evolutionary terms. So let's just watch the video to the end to see a polar bear in action. There you go. Amazing images. So they can swim and they can chase a seal underwater, keep not breathing, so keeping a apnea for I don't know how long maximum, and have strength enough to capture a seal underwater and bring it up to the surface. There you go. So for me, this is the perfect example of how the evolutionary forces pushing mammals to the sea. Okay. Now, the same thing is happening to otters, right? Now, otters belong to a carnivora family which is the Mustelidae family, which is in fact very close to bears, to the Ursidae family. And it's many of the otters and the mustelids are aquatic animals, right? Most of these aquatic otters are in rivers, but some of them have made an adaptation to the sea, right? The most well-known is the North American otter, and we're going to see some images of it. But there are many other otters all around the world, in South America, in Africa, and even in Europe. Now, the biggest in terms of size sea otter is the North American sea otter. It had a huge extension all across the Pacific ring, so from California and Mexico, from Mexico all the way out to California, Alaska, and then Asia going into Japan. And these animals, I think I have of course, we all know that they are very cute little creatures. And if you have a look at this slide, it will show you that they have an extraordinary adaptation to living in very cold water, which is their fur, right? So they have this very thick fur. It's actually the thickest fur in the mammals. So they have the highest number of fur follicles per square centimeter, and the way that the furs are also the fur as adaptation. So they have two layers of fur, and the external layer as an adaptations to seal the lower layer, and in top of this they produce a lipid agent which they constantly put on their fur to keep it to make it waterproof, right? Now, this skin was responsible for the almost extinction of these animals, right? And they were hunted to literally to extinction. The people thought that the sea otters were extinct, but they managed to survive in small groups, and now slowly they are recovering, and they are again colonizing their environment again. And clearly in this case what you have is again an adaptation to food, right? So again is food that is leading the adaptation of these animals to the aquatic environment. They prey on crabs, they prey on sea urchins, and all this coast of South and North America is clearly an example of a big difference in productivity between land and the sea, particularly in animal food, right? So for a carnivorous animal, it's way much easier to catch a crab than to catch a rat, for instance, right? Or a rabbit. And so there's clearly an evolutionary force driving otters or driving mustelids, I mean, to the water, and particularly to the sea. So this is a series of slides. I'm going to skip them. Series of slides about other species of marine. Right. So I guess that's the main topics I would like to summarize for you in this time, and so we conclude here this revision of what are mammals, and what are the marine mammals, and what takes marine animals into the sea. Is there any questions that you want to raise now?
Could you repeat if you said it? I don't know if you said it. The main characteristic of mammals. What does define a mammal?
Oh, well, if you go back enough, it has to do with the bone structure, with the structure of the skull. So mammals have this synapsid skull. So if you go way back to the first tetrapods, the first amniotic tetrapods, you would, as I said, you would see lizards laying eggs, and the only difference between them was in the skull, right? But then they took different evolutionary paths, and the synapsids evolved into a nocturnal niche. And so very early they must have evolved, what's the name of this, warm-blooded animals. So poikilothermia, and fur to keep the heat, right? Because they evolved because all the ecological niches were colonized by reptiles, so by diapsids, and so they evolved into nocturnal animals, and so there is cold in the night, and so being warm-blooded is an advantage. So in this group, fur as a isolation mechanism, because they were developing warm blood, and eventually the development of the internal development of the embryos, and this led to the development of milk. So marsupials first internalized the egg. Well, they got rid of the egg, and so they have the egg start developing inside the female, but was born very premature development, and the rest of the development of the embryo happened outside of the female, and so they needed food, and they probably started by the evolution of the milk production was presumably from, how do you call this, from sweat glands. So the same glands that would produce sweat evolved to produce a nutritive liquid, which the embryos would lick, and then eventually these dispersed, which we still see in monotremes apparently. So in monotremes don't have nipples; they just have an area where milk is produced, and the juveniles just lick it. But then eventually this formed glands and formed nipples, and the marsupials, the little embryos, just grab this nipple and they feed from their mother. And so that's the other thing that defines mammals is milk.
Okay.
So those were the three main basic features of mammals. So not placental, not the direct development, because you have mammals with eggs. Good. Okay, so now let me just stop the recording here.